I want to, actually, you know what I want to do today is I want to go back to that radical problem. I don't want to start another section just yet, because I don't think I put the percentages on the test. So I'm going to go to that problem, and we're going to work through those percentages. Because the next section is really, it's a big section. I mean, it's all a bunch of reactions. And I'm going to introduce it today, but I'm not going to, like, we're not going to start it until I send y'all a list of videos to watch.
Did you post any handouts yet?
Not yet, not yet. It's going to be, the next handout is in the next section, the next module.
Okay.
But I'll open it up after today. All right, we're gonna go back and revisit this radical problem. We might just work another one, just for the sake of working it and going through the percentages. Because I think I felt like I kind of rushed through this Friday. That's why I didn't put it on the test, but it definitely will be on the next exam. And I only got 5% on my iPad, so if the iPad dies, I'll just leave the camera on and turn it towards the board so you can see what we're doing. All right.
Excuse me.
All right. So the last question that we did was right here. We talked about the different components of this equation to calculate percent the product distribution for radical substitution. And I gave you this equation right here. It's coming up. I'm waiting on the projector so the people in the classroom can see it. All right. So I gave you this equation, right? And that, it looks like funky looking, but it's really not. There are three parts to this equation. NH, well, two parts really, NH and R. R is the reactivity factor, and then NH is the number of the type of hydrogen. So if you got secondary, primary, tertiary, like that, that's what that means, right? So we did it for this one. We said that there were, let me go back to here, two types of secondary. The ones highlighted in orange and then blue, and then two types of primaries. And again, I want to reiterate, when you're doing the mechanism, if you got identical types of hydrogen, you don't have to show both types reacting. But when you're calculating the percentages, you got to include everything, because both are equally susceptible to react. So let's go back to here. All right, so I said up here that for secondary, if we're just doing the sum of the secondaries, N is 6, right? Because we got 4 of them in orange and 2 in blue, but we'll total them up for that sum. That's the denominator value. All right, are y'all following that? So the sum here in the denominator, that's everything all together. So secondary plus primary plus tertiary, whatever. Following? Yes, no?
Yeah.
All right, y'all following that online?
Yes.
All right. And then in the top is the part over the whole, basically it's a fraction. So whatever the part is. So let's go back over to here. Right, and we talked about the primary. There are 6 primary hydrogens. And then we also calculated the sum down here, right? We said that this was 3.9 was the reactivity factor for chlorine. And then we said that there was 6 primary or 6 secondary, so that's that number. And then for primary, we had 6 numbers, 6 hydrogens, and then R is 1. The reactivity factor is 1 for those. So that's 6 times 1. So that's how we came up with the number, the sum of 29.4, which I used right here. Following? Any questions about that? We're gonna do another one, or we can walk it down. That's all we're gonna do. And then we're gonna stop early. All right. So for the primary in the top, right, that NH times R, NH is 6. There was 6 primaries. R is the reactivity factor, which is 1. So 6 times 1 is 6. So that's the number in the top. So when we divide those two, we get 20.4%. All right? If we do the secondaries, we're gonna split those up because they're two types and they're gonna give you two different products. So we're gonna say for the secondary, right, we got 4 of the orange ones. They don't look orange to y'all because this projector is crap. But these right here. And then 2 of the pink ones. Right? So we want to calculate the percentage for the 4 orange ones. This is what we do. This is NH, which is 4. This is R, which is 3.9. We got that off the chart. Divided by the total, right? 29.4. And then we take that and multiply by 100. We get 53.1%. So over half our products are going to be those secondary hydrogens. The ones highlighted in orange. Yes, no? Got questions? Questions online, on Zoom. All right. Then when we do the other two, the 2 ones in the middle, sandwiched in, excuse me, the pink ones, right? You can see this is NH right here. Uh-oh. NH, and this is R. Multiply those together, divide by the sum. That's why we calculated the sum first. So we don't have to keep doing it. Once you calculate the sum, it's going to be the same denominator for every one of those fractions. Right, and we take that, that's 7.8 divided by 29.4. That ends up being 26.5%. So the total would be 100, right? 20.4, 26.5, and then 53.1. That would be what? 46.9 and 53.1 is 100%. Right. All of your products have to add up to 100%. Any questions about that? All right, let's do another example. I'm gonna take the example that was on the exam. I think it was. Look at this. Is that right? I think that's- Right. Let's take that. We're gonna treat it with. Come on out there. All right. We're not gonna go through the mechanism. I just want to get to the products, and then that way we can figure out the percentages. Right. These 2 carbons are equal. Right. So in the product, when we're coming up with the products, you're not gonna get 2 products from there, but you are going to get a product for each one of the other ones, because they're not the same, right? You want to get a product from this, and so those 3 plus one of the 2 branches. But those are the same. And the way you know is if once you make the product and you put a chlorine or bromine on one and a bromine on the other one and compare them, it's the same exact thing. All right. So where are my products? Well, not me saying not where. What are my products? If we're doing radical substitution with bromine under UV light, what products am I going to get from this? Without going through the mechanism, initiation, propagation, termination. What are the products? Again, the BR2 mean, what does that mean? What am I adding? What am I substituting, first of all? Because that doesn't change. I'll take off a hydrogen and replace it with a bromine. Is that right? So each one of these locations is going to get what? A bromine. Is that right? Yeah. Yeah. I can't even imagine homecoming. I'm sorry. Woo! I'm sorry. I won't be able to sleep for homecoming. Hurry up, please. Hurry. All right. So let me just write the products out, and then maybe we can, yeah. This is that. I'm gonna write this one first, because that's the easiest one. You okay with that? And let me put the CH3 back in. And then my other product looks like this. One of my other products. Is that right? The green highlight is. One of the other products is going to look like this. Yes or no? Yes, no, maybe?
Yes.
Where the yellow highlight is? Yeah. And then the pink highlight, again, those two carbons are equivalent. So I'm only going to draw one of those products. Everybody okay so far? All right. I'm gonna write it on the board too, because I know this thing is in the guy, this iPad. You gotta be freaking kidding me. That's all right. I gotta shoot for that too. Yeah, full battery. All right. Never fear. My computer battery is also dying, but I'm gonna log in from my phone because I got a feeling when the iPad dies, we'll have to have some other way to communicate it. So just hold up. Switch between. All right. So with these, we have a tertiary product. We got a secondary right here. We also have a primary here and another primary here. All right. But when we're calculating the sum, we don't care where the primary is. We're going to have to lump them all together. So how many primary hydrogens do we have? We got 3 here, 3 here, and 3 here. Is that right? So we got 9 primary hydrogens. This is just to calculate the sum. How many secondaries? Two secondary hydrogens. Is that right? And then 1 tertiary hydrogen. Everybody okay with that so far? All right, so when we're calculating that, we're calculating the product distribution. It is NHR over sum of NHR. Right, R is the reactivity factor, NH is the number of each type of hydrogen. So let's go back up here, let's get R for bromine. So for bromine, it is for a primary carbon, it's 1.0. For a secondary carbon, it's 82. And for a tertiary carbon, it's 1640. So somebody, 1640. All right, we good so far? So let's get the sum down here before my iPad passes away. Right? So it is going to be in the denominator for primary is 9. Is that right? It's NH, that's 1. 9 times 1, because the reactivity factor R is 1 for primary hydrogens. And then that's gonna be plus the secondary, we said we had 2 secondary hydrogens. So it's gonna be 2 times 82 plus 1 times 1640. And this is my sum. Secondary, this is. Are we following? Anybody not following? So 9 primary hydrogens, 2 secondary hydrogens, 1 tertiary hydrogen. And then the R is different for each one. R is 1 for primary, 82 for secondary, and 1640 for tertiary, with no units. Because we just calculate percentages. Questions online? What do we get from that? 2 times 82, what is that? 164 plus 9, that's 173. And then 1640 plus 173, what is that? 1813? Is that right? Huh? Oh, okay. Take your time. Where did the 82 come from? Okay, that's the R. For bromine and secondary hydrogen. Okay. All right. So secondary is 82, tertiary is 1640. What? 1733. I knew it. All right, my iPad just quit on me, so give me 1 second. Because I'm just gonna, we just don't have to rush. I'm gonna have to combine these recordings, so that's gonna take a minute. So I gotta splice them together, but I'm gonna make it work. We got it? So primary A, and then secondary, primary B. And the only reason I'm saying that is because I want to know specifically how much of 1 primary B I get as opposed to primary A. You understand? I could lump all the primaries together even when I'm calculating the percentages, but I don't want to. So I want to know how much of each specific product I'm going to get. All right. Any questions so far? All right. So let's calculate the amount of secondary. Let's do that. Oh, this pen is not working. Hold up. So I got another pen. Okay, that's better. So the secondary, again, is NH R over the sum NH. That's all I'm doing. It's just a fraction, part over a whole. So for the secondary, it's going to be 2 times 82. This is NH. That's R divided by the sum, which is 1733. Yes or no? Right, and that doesn't change. All I'm changing is the top number. Once I calculate that sum, it's a wrap. I don't need to calculate it again. That's why I always do that first. And the way you calculate the sum is to know the reactivity factor values, which are given in the table, as well as the number of each type of proton. Go ahead.
So I got like 18. Are we adding all those numbers right there? So I got 9, 164, which is
173. And then 16, we said 1813? Okay. All right, it is. Okay, let's get it right. 1813. All right. So if you're online, adjust the total sum to 1813 instead of 1733. So we're going to change this over here as well. And then we're going to multiply that by 100. That'll give
How did you get 1813?
Okay, so we had 9 primary hydrogens times 1, which is the reactivity factor for bromine. And then we had 2 secondary hydrogens times 82, which is the reactivity factor for bromine for secondary hydrogens. And then we had 1 tertiary times 1640, which is R for bromine for tertiary. So this is 9 plus
164 plus 1640. It's 1813. Can somebody calculate that percentage? 2 times, what is it, 164 divided by 1813? Yeah. Anybody? This is probably the most math we're going to do all semester. And it's still easier than GChem, I think. Anybody got it? Chase, you got it?
I'm working on myself. I didn't stuff, so.
It's okay. Every mistake is redeemable. So 9.05%. So what that means is, and this is for secondary, that for this product right here, secondary product, 9% of the total is going to be that. 9%. That's what that means. Let's do the tertiary. So that's 1 times 1640 divided by 1813 times 100. Right? What do we have for that? Most of our product is going to be that. You can see that's probably going to be about 80% or so, somewhere up in there. And y'all can calculate, if you're on Zoom, you can still calculate it and, you know, yell it out, unmute. Don't put it in the chat because I can't see that. Because I'm like Spike Lee and trying to teach at the same time. So I'm making my directory. This is the first time I've ever done it. Had to do this. But hopefully the camera work is not too shaky. Anybody got it? 90.5%. All right, good. Now let's do primary A. Let's do that. That's this product right here. So remember for that, this was a CH3 in the starting material. So this is the primary A that we're talking about. So how many hydrogens do we have here? 3. So that's going to be 3 times 1 divided by 1813. That's how we're going to times 100. That's how much. That's how we know exactly how much of that product we get. What you got? Anybody? You got the right calculator. I like that. Simple. They don't have no rocket engines
Wait,
on it.
did you change the number? Like, I thought it was 9 times 1.
The top number?
For primary, I thought it was 9 times 1. So now
Okay,
we're
great
doing
question.
3.
You're right, because you're right. It was 9 times 1 when we did the sum because we don't need to separate them. But over here, this set of primary hydrogens is different from these. Following? They're not the same.
Why not?
Oh, good question. Now you give me a chance to do some nomenclature. So let's name this product. Right, we're going to start. Let's see. That's right there. Let's name that product. So this is 1-bromo, 3-methyl. I might. Butane. Following? I number from here because at that carbon I actually have an atom, a branch, right on the carbon. So it's 1-bromo, 3-methyl butane. Now we name the other product here. This is 1, 2, 3, 4. This is 1-bromo, 2-methyl butane. Those are not the same. Those are constitutional isomers. Are you following that? So me putting a bromine on this carbon, which is the same as that one. So if I put it there, it's going to be the same thing. If I put it here or here, I'm going to get this. If I put it here, I get this. If that makes sense to you. So it's 2 different products. So that's why I separated out one primary A and then that's why I named these primary B. So that's why I'm only using 3 right here.
So now that it's separated, we just add them together to get the answer?
In the sum, we added them together, right?
Okay.
Because they're all primary. So they're all gonna react the same way, it's just gonna give different products. So that's why I just lumped them together here in the sum. But when I want to get specific about how much of each product I'm getting, then I break them apart. So I'm gonna have 3 for primary A. What do you think I'm gonna have for primary B? Because this is primary A, this is, both of these would be considered primary B because they're the same. How many would I use for that?
You, s-
So
repeat that again?
primary B would be these hydrogens right here.
Right,
How many would I use over there in the numerator?
would be 6,
6, for a total of 9, is that right?
right?
Hmm? So over here, for primary B, it'll be 6 times 1.0 divided by 1813 times 100. Does that make sense to you now? More sense? Because since those are 2 different products, I want to know how much of each one I'm going to get. And there's not much left because there's only 1% of product left. Is that right? This is 9% and that's 90.5.
Mm-hmm.
There's not much left. So what do we get for primary A? It says 0.17. Okay, what about B? 6 divided, that should be 0.34, right? If this is 3 and that's 6, and that top number doubles, then the fraction should double. Which total them up and it's 0.51, right? So we all, yeah, so we'll have right at, it should total up to 100%. Yeah. All right.
One B, would that be 6 instead of 3 because like you're adding the other?
Yes. Mm-hmm. Because remember, when we're calculating the sum, we can lump them all together. But over here, right, these two are the same. So both of them are equally reactive. So I won't just use 3, even though when I do the products, I only use one of them. Both of them can react. So I got to take that into account. So that's why I count all 6 down here instead of just 3. All right. Any questions about that?
For this equation, we're calculating the product, right?
Yes, the percentage of each product. Yes.
But I thought the one with the 3 CHs, that wasn't a product.
Which one?
That one right there where primary B.
Primary B.
Yeah.
Right here.
No, up there at the top.
Here. This one.
The one farther to the left.
Here.
Right.
That's my starting material.
Right. You started with that one,
Mm-hmm.
but you calculated it as a product.
Yeah, but I did radical substitution. And in radical substitution, each one of these positions is going to get halogenated. So this is where I'm counting my hydrogens on the starting material. Because those hydrogens get pulled off in propagation. Is that right? If I went through the mechanism and showed it, this hydrogen will get abstracted. One of these will get abstracted. This one will get abstracted. And then one of these will get abstracted.
And we don't use the other product that combines all the CH3s and the bromine.
When you say other product, what are you referring to? That's a good question. I just want to get to the meat of it so I can answer it the right way.
Like when you first did it on the iPad, you wrote
Mhm.
it as that first equation as your first thing, and then you transferred the bromine and connected
Mhm.
it with the CH3s,
Right.
which was
But
the first product you wrote.
okay, let me see if I can make it a little clearer. So let's say we took one of these in propagation, right? This is what's happening. I just didn't show the mechanism, but I'm pulling off one of these hydrogens right here. to give me a radical like that. And then this, I'll terminate with a bromine radical to give me that product.
Right, but that's not like the original problem you wrote on your iPad. That's what I'm confused on. Like, it just looks different than what you wrote on your iPad. So I was like, am I
Did I
making
have
this up?
Did I have another carbon in there or something? There was 4 carbons, right? I'm just trying to figure out, like, when you
I
say
know. I
different,
wish I could show you.
when you say different though, but I wrote it in skeletal form. That's the only difference. And then I
Okay.
put the 2 hydrogens here, like that. Is that right? That's what we had. Where is it? Here. It's the same, it's just the way that the bonds are.
Okay.
All right. If it's still confusing, I'll be happy to kind of walk back through it with you. I don't have a problem. All right. But let's look at the percentages, and let me just touch one more thing, and then I'm gonna dismiss class, and you can stay and ask all the questions you want, if that's okay.
Yes.
Okay. All right. Cool. So, question is, based on the percentages, which one of these is major? What do you think? You got 9%, 90.5%, 0.17%, and 0.34%. If I ask you what the major product was, what would you say? The 90.5%. Now, I'm asking this on purpose, right? What is that 90.5% correspond to? Which one of these hydrogens got pulled off in propagation to get to that product? This one, this is the product right here. That's the product that corresponds to 90.5. So which hydrogen did I remove? Wouldn't it be here, this one? Is that right? Does anybody disagree with that online? What type of hydrogen is that? Primary, secondary, tertiary? It's tertiary. And it just so happens that that's the most reactive out of all the hydrogens in this molecule, right? There's a reason for that. When we talked about carbocations, do y'all remember that? And stability, what's the most stable carbocation? Tertiary. Tertiary is the most stable, right? Primary is the least. So it's the same thing with radicals. When I make this tertiary radical in propagation, because this is the radical that ends up combining with bromine, if y'all can see that, to give me that product. Probably should have gone through the mechanism. What I'll do when I post the notes, I'll put the mechanism in there. Right, so so it's that tertiary radical, right? That's the most stable out of all of them. That's why you get more of that than any of the other, right? Because this is the radicals and cations follow the same stability trend. Right, that's my most stable radical. So that hydrogen is going to come off faster than any of the others, even though it's tertiary. And even though bromine is like, that's like trying to fit Sherman clump into a mini Cooper. Big, gigantic atom, tight space because it's tertiary, but that's what happens. And that's why you get 90% of that in the product, because that radical is so stable that abstraction happens rapidly compared to the other hydrogens, right? The primary is in the secondary. Secondary, you can see it's 9.5%, 9.05%. All right, questions about that part? All right, what I'm gonna do, I don't wanna start alkenes yet, so I'm gonna stop here. I'm gonna give y'all 4 minutes of your day back. Make the best of it. By the time you get down the stairs, it'll be gone. All right, I couldn't see who that was asking questions about the hydrogens, but just stay put. Or you can start asking now and we can go back through it.
Yeah, that was me. I don't know. It was, I got on the last one, but it was like, this one just kind of like threw me off a loop. Like, I don't know.
Okay, so let me ask this question. Which part, this is sloppy too, by the way, but which part threw you off? And let's start there.
Right after we wrote the product, the core product, like that's when I was like, okay, fine.
All right, let's do this. Okay, y'all take care. Let's start. All right, you too. Let's start over. We'll start over. And I'll erase all the products and all that stuff. Because I know it looks different when I put it on the board because I didn't rewrite everything. All right, are you okay with the sum and NHR and all that stuff? You good with that?
Yeah, like it's just like the formula. And then you calculating the bonds to figure out if there's primary, secondary, that I was
Right, so I started with this. Is that right? Is that right?
right.
That's what we started with. So each one of these, so I got 2 hydrogens here that are secondary. You agree with that? Because this is a secondary carbon. Do you have your hand up, Savannah? Go ahead. Or maybe
Yeah,
that was,
sorry. If I needed to schedule office hours, would you just email you? Or is
yes.
there? Okay.
Yep, you can email me or you can shoot me a text.
Okay, thank you. Have a good day.
You're welcome. You too. All right, you see it, Nancy, at that secondary?
But I thought you said that one was primary.
This carbon right here is secondary because it's bonded to 2 carbons. So it's bonded to a carbon on the left and on the right. So that carbon is secondary. This carbon right here on the end is primary. That's primary. Primary. Because it only has one other bond to carbon. This one is tertiary. There's one hydrogen here. But that carbon is tertiary because it has 1, 2, 3 bonds to carbon. Is that right?
Right.
And then both of these are primary because they're both bonded to 1 carbon, but they're equivalent. So that's primary and that's primary. But they're not the same as the primary down here. We're following that?
Can you hear me?
Yes, I can hear you.
Okay, great. Yeah,
We
I
good?
got it.
All right. So we got this. We don't need this part over here. So I'm not going to write out the mechanism, but I'm just going to write out the radicals that we'll get. So in propagation, I'm going to get a radical here, right? One of these is going to get pulled off. I'm going to get that radical. From there, I'm going to get a radical here. Still got 1 hydrogen, but I'm going to have a radical right there. And then I'm going to get a radical here. Right there for that tertiary hydrogen that's up here. See that? And then I could get a radical at either one of these sites, but I'm gonna pick the top. But they're both equivalent, so if you were to pick the bottom one, it wouldn't matter. So then I'm gonna get that right. So that's 4 different products. Does that make sense?
So we're just breaking off pieces of the original just to calculate it?
Yeah, that's what the
Okay.
reaction is. If I take this alkane plus Br2 and shine light on it, I'm gonna end up with it's a radical substitution. So I'm gonna add a bromine to every site on here where I can pull a hydrogen from.
Okay.
Mhm. So then if I terminate this, right, I'm gonna get a bromine right here on this carbon. The CH2 that's right here, I'm gonna add it. This is termination. I'll get a bromine right there. All right, if I terminate this one with a bromine radical, and I'm gonna get a bromine at that secondary site. So all of these products I'm gonna get from what we call radical substitution, but it has to go through the process, initiation, propagation, which is where we would get all these radicals from, and then termination, where they pair up with the initiator. So if I put a bromine here, those two are coming together, and then I'm going to get a bromine at the tertiary site. So this is where all my products come from. Same thing here. If I terminate that with bromine, this is the product that I'm going to get.
Okay.
Right, so I got all 4 of these products. So now all I did over here was calculate how much of each one of those products I got. But to do that, I need to know the number of secondary hydrogens. This was the tertiary, which we already saw over here. I have 1 tertiary hydrogen, 2 secondary hydrogens, and a total of 9 primaries, but I'm breaking them up into 2 different products because they're not the same. So there'll be 3 primary for here. I think we call that one primary A over here. And then 6 primaries for these 2, which we call primary B. That's how we got those numbers, the 6 and the 3, and the 1 and the 2 right here.
Okay.
Does it make more sense now?
Mm-hmm.
Good. All your questions answered. That's the other part.
Yes.
Okay. All right, cool. So yeah, I'll clean up the notes once my iPad charges, and I'll post it, and I'll put some extra little notes in there to clarify like why we did what we did. And I'll put the mechanism in too.
Okay. Thank
All
you.
right. Yeah, no problem. Thank you. That's a great question. Yeah. If you have got anything else?
No, that's it.
All right, good. Have a good day.
You too.
All right.